we will discuss how a body moves in a circle. Body in a circle with steady speed or constant speed. When I say steady speed, means its speed will remain constant at every point. Suppose this is the circle in which body moves. In the center, this is the body of mass m is moving here in anti-clockwise direction. Here is point A. It has a velocity Va at this point. Va velocity. When it reaches at this point B, this velocity is always tangent to the circle. This is the Vb. And when it reaches at this point Vc, this is the velocity is Vc point, and the velocity is changing. You will see velocity is changing, although speed is same. That's why I have drawn these arrows almost of the same length. Although I have not the ruler, but almost these length of the, suppose this 5 centimeters should be 5, this should be 5. Although I have not drawn accurately with the rule, but almost they are of the same length. This shows that the speed, there's the magnitude of Va, magnitude of Vb vector, magnitude of Vc vector is constant, and it is just the speed V. Now speed remains constant in the circle, but if the velocity would changes due to change in direction, you can see it has this direction, it has this direction. Suppose this is north, this is supposed to be west, or this is another direction. If body reaches here, this is another direction. It will be moving in this way. So direction changes, hence velocity changes. Now since velocity changes, body is under acceleration, because you know acceleration is defined as a change in velocity upon time. This is the change in velocity upon time. This is not change in speed. So clearly body is accelerated. When the body is accelerated, Newton's second law says there must be a force. F is equal to ma. So acceleration and force are in the same direction. When we say there is a change in velocity, there must be a change in acceleration. And if there is a change in acceleration, there must be a force which is causing the change in acceleration. And that force is known as centripetal force and is directed towards the center. If this is directed towards the center, the acceleration should also be directed towards the center at each point. This force acceleration. When the body reaches here, force will be directed here to the center, and acceleration is also directed here to the center. So always keep in mind, according to this Newton's law, force and acceleration same direction here. Force and acceleration are in same direction, and they are directed toward the center. Towards the center of the circle. When they are directed towards the center of the circle, I can't say that the direction is changing. The direction is changing. See, this force is directed here, and suppose the body reaches, the force will be directed here, and acceleration will be directed here. So the direction of force and acceleration changes. But keep in mind, magnitude remains constant. Actually, there are 4 variables here which change, but their magnitude remains constant. First one is the velocity. Velocity is what changes, but its magnitude, which is speed. Speed is constant, velocity is changing. Similarly, acceleration is changing due to change in direction. The different acceleration has a different acceleration, but its magnitude remains constant. Magnitude is constant. Similarly, other thing is force. Force changes due to change in direction, but its magnitude remains constant. Similarly, the momentum changes. Momentum changes, but its magnitude remains constant. So there are 4 quantities: velocity, acceleration, force, and momentum. They all change only due to change in direction, but their magnitude remains constant everywhere. Now, what are the direction? I told you the acceleration and force will always be directed toward the center. Both will have the same direction. Velocity is always perpendicular to the force. Velocity will always be perpendicular to force, and also velocity will be perpendicular to acceleration. I denote by FC. FC means C is a subscript for centripetal force or centripetal acceleration. So we will always at each point, you will see this is 90 degree, this is 90 degree, this is again, this will be 90 degree. Why? Because these are the two prerequisites I discussed in the previous lecture, that the magnitude of force will remain constant and this velocity must always be perpendicular to force. These must have to be fulfilled so that the body moves in a circle. So these are the two prerequisites which I discussed earlier, and due to that one, the acceleration changes, force changes, velocity changes, momentum changes. Okay, but sometimes examiners ask, what is the work done in the circle or entire circle? Some students think the work done is 0 up to entire circle here. Okay, it is 0, but they say since displacement is 0 up to entire circle, there this reason may be valid. But when I say what is the work done in a part of a circle, work done in a part of a circle is also 0. But they cannot give this argument there. Actually, there are two main proofs saying the work done in a part of a circle is 0, a horizontal circle I mean, and work done in entire circle is also 0. I can prove in two ways. I can give the work in the equation. Work done is change in kinetic energy plus change in potential energy. First method I can prove the work done is 0. I can say work done change in kinetic energy plus change in potential. There is no change in kinetic energy because speed of the body is constant. Kinetic energy 1 upon 2 mv square, mass is constant, speed is constant, so kinetic energy doesn't change. Then potential energy is also 0 because height is same, body is moving in horizontal circle, so work done is 0. First reason. Second method is I can say we usually calculate by work done. Work is always equal to FD cos theta. So this is FD cos 90. Why the angle is 90 between force and displacement? Here the angle between force and velocity is 90. Now velocity and displacement are always in same direction. Velocity and displacement are always in same direction. So if force and velocity are perpendicular, similar is the case that force and D will also be perpendicular. I am representing by D. So I will say FD cos theta so 0. So that's why the satellites which are moving in their orbits in a horizontal circle do not require any energy. Once they are given the energy, they do not require more energy. Now I have to derive some formulas for the centripetal acceleration. First of all, suppose if this is a body, a same body mass m, it is moving in a circle of radius r with speed v. Steady speed v. This radius r. Now what formula you have to recall? That centripetal acceleration is equal to v square upon r. This is the formula which you have to recall. Other formulas will be proved by using this thing. Now I am writing here those formulas which I will be driving. First here, first is centripetal force is mass into centripetal acceleration. Fc is equal to msc. Here is nothing formula. This is the basic one. Now other thing is here AC is equal to V square upon R. I can multiply here FC is equal to mv square upon R. Whatever the centripetal acceleration formula comes, just multiply by m. Now again I will prove another formula that's I can say but V is equal to R omega. So I can say AC will be equal to R square omega square upon R. R is cancelled with R, so it's R omega square. I have proved. So I can say AC is equal to R omega square also. And centripetal force will be equal to mr omega square. Actually, these are the two formulas which are very important, mv square upon r and mr omega square, and this one also. You should remember these if you wish, but other formulas you should know how can they be derived. For example, I can go further. I can say omega is equal to 2 pi upon capital T. So centripetal acceleration will be r into 4 pi square upon t square. So it's 4 pi square r upon t square. So centripetal acceleration is 4 pi square r upon t square. Here I write Fc is equal to 4 pi square r m upon t square. Then I have since F is equal to 1 upon t, so I can write centripetal acceleration is equal to 4 pi square r f square. So I can write here centripetal formula 4 pi square r F square, and here centripetal force 4 pi square r F square m. Similarly, there is a one very important formula. Sometimes they say to prove that AC is equal to V omega. They say prove that AC is equal to V omega. This is also the formula, speed into angular speed. Both speeds in terms of. This formula is somewhat, students feel it's very difficult to define. This is a very important thing. You should know this, how this is to be proved. Now this AC is equal to V square upon R, but you know V is equal to R omega. You have to just eliminate R, so R is equal to V upon omega. Just put here R is equal to V omega. This becomes S is equal to V square upon R is V upon omega. Now this omega is dividing, so V square divided by V upon omega. It is V square into omega upon V. V is cancelled in square, so AC comes out to be V omega. So AC is V omega, the formula, and here FC will be equal to mV omega also. Since you know V is equal to the omega is equal to 2 pi upon T, I can write this V 2 pi V upon T. I can write FC is equal to 2 pi Vm upon T. So the various formulas can be made in that way, but only the basic formulas I will be telling you. Those are the two basic formulas. FC or I'll say AC is equal to V square upon R omega square, or V omega. You can remember these three formulas, and FC then becomes mV square upon R, mR omega square, or mV omega. So always a centripetal force is required to make the body move in a circle. But I tell you a caution of warning. A caution of warning is that centripetal force is not a new force. When you indicate the body diagram, you should not include the centripetal force in your body diagram, because centripetal force is equal to someone which will be supplied or which will be provided by either by the friction, either by the electrostatic force, either by the gravitational force, either by the tension or any other means also. But it is not a separate force. For example, if this is the sun and Earth is moving around it in a circle, Earth is moving, suppose this is the sun and Earth is moving around this in a circle, this one, velocity v. Now actually when Earth, there is the force of attraction here. There is the force of attraction, gravitational force is directed. Sun is attracting the Earth, and that makes the gravitational force, and that is equal to centripetal force. But so I will say Fg will be equal to mv square upon r, but there is no mv square upon r is not a new force. It is provided by the gravitational forces which is equal to that one. Actually that is a formula only, but there is mv square upon r is not a new force, and there is nothing like the centrifugal force. Some students think the body is in equilibrium and there must be a centripetal force, or there must be another force which is centrifugal force. If there would have been centrifugal force, body would not have been accelerating. They have been cancelling each other, but there is acceleration. Body is not in equilibrium. So centripetal force is not balanced by any other force, but centripetal force is provided. For example, when electrons are moving around a nucleus, I will not say the centripetal electrostatic force is directed towards the there are two forces directed towards the nucleus, one is the electrostatic force and the centripetal force, but it's not incorrect. I will say only and only electrostatic force is directed towards the center of the circle, which is equal to the centripetal force. Similarly, when I say Earth is revolving around the sun and there are two forces, suppose somebody says there are two forces, one is the gravitational force which is directed towards the center of the Earth, and also the centripetal force is directed towards the center of the sun, center of the sun, and gravitational force directed towards the center of the sun. Actually, it is wrong then. It is only and only one single force, which is the gravitational pull of the sun towards us, which is making the Earth to move in the circle. It is providing the centripetal force that is equal to centripetal force, but the centripetal force is not an other force.